present my work. Am I audible, no?
Yes, yes,
Yeah.
you are very well.
Yeah. So thank you for the opportunity, sir. And also, I would like to thank our director, sir, Dr. T.B. Shri Kumar, and our consultant, Dr. Ashok Desai, sir, for encouraging and support. Okay. So my name is Smita Baride, and I'm going to present this topic: characterization, synthesis, and applications of conducting polymer-coated fabric. Now, before going with the presentation, I would like to inform you about my organization, that is BTRA. Yeah. So, as we all know, BTRA is established in 1954 by textile mill owners and government of India to basically boost the research and development and innovation to our textile industry. Currently, BTRA is a approved body of Ministry of Textile, Government of India. BTRA is actively involved in the technical and consultancy services, training services. BTRA has got many research and development R&D projects from various funding agencies and industry-based projects. BTRA is a ISO 17025 certified and NABL accredited lab for doing the testing to our textile industry, that is physical testing lab, chemical testing lab. We have polymer FR testing lab. Out of that, one of the lab I'm handling, that is a conductive textile lab. So in my upcoming slide, I will show you some of the facility present in our lab. So basically, what is conductive fabric? So conductive fabric is a fabric which is able to carry a current, where conducting substance is applied or deposited over non-conductive substance. Now, any untreated sample or control sample is basically non-conductive or insulating, because it is having a very high resistivity, that is greater than 10 raised to 10 ohms per square. Now, when we applied some conducting substance over it, the resistivity is getting reduced, and that is becoming conductive. So here basically a non-conductive substrate is our normal fabric like polyester, cotton, nylon, etc. And conducting substance can be the conducting polymers, metal fiber, filament, or carbon powder, CNTs, etc. So as I said, our normal fabric is an insulating one having resistivity greater than 10 raised to 10. When becoming conducting, depending on their conductivity, these fabrics can be used in wide range of application. Now, comparatively less conducting sample can be used in the EST protective garment or for anti-static clothing to dissipate the static charge generated in the areas like oil mines, gas industries, fire, electronic, etc. It is basically used to dissipate the static charge generated over the fabric. And this kind of application is needed in these areas, hospital, gas industries, etc. And the product based on these applications are shockproof carpet, or ESD protective uniform garments, etc. In the pharmaceutical industry, also for drug filtration, they are using anti-static filter. Basically, see, when they are doing drug filtration, there is a formation of static charge. So to avoid that, there is some conducting element incorporated in that filter, so that the static charge dissipation will be there and smooth filtration can be there. So this kind of applications are coming under the anti-static clothing, which is having a low conductivity, resistivity ranging between 10 raised to 6 to 10 raised to 10 ohms per square. Now, very highly conducting samples can be used for EMI shielding application. This is basically to attenuate the hazardous electromagnetic radiations which are generated in the areas like electronic or in the medical field for checking and all, be exposed to x-rays and all. So there is a need for this EMI shielding fabric. Also, in case of stealth technology, for security purpose, shielding products are needed. They used to have a very high conductivity in the textile, which is ranging from 0.01 ohm to 10 ohms per square, which is basically a metallic enclosure, we can say. And the product based on this application is a radar absorbing material or shielding curtain, we can say.
Hello. Huh?
Hello. So so these are two
Poly
categories: less
2105 है
conductivity and
जो
high conductivity. Now there is a
हाँ
medium
हाँ हाँ
conductivity textile range. So that can be used for heat generation and in the smart textile application. See, being a conducting material, they are having some low resistance. When we apply some voltage to that, it will increase the current flow and convert it to dissipate heat. So, so with that phenomena, this material can be used as a heating element. And that's why the conductive textiles are generally used as a heating element in the for the high altitude clothing like warming jacket, warming glow, etc. Also, they are using as a heating element in the heating pad. Also, this conductive textile having a special phenomena many times that they can sense and react with the external stimuli. So they are acting as a sensor and transducer or transmitter in many applications. This basically it is reacting to the external stimuli so that they can use as a sensor and transducer for the wearable electronic and in the medical field. Medical and sports wearable, this thing. So the product based on this are basically a ECG sensor, wearable sensor, our sports related athletic based product, etc. Even gas sensor. In the gas sensor also the conducting fabrics can be used. I will show you one of our prototype how we can able to use that conducting material as a gas sensor. So as I said, depending on the conductivity, this conductive textile has a wide range of application. So very highly conducting fabric, as I said, can be used for EMI shielding. And the resistivity range there is basically from 0.01 ohms per square to 10 ohms per square. The medium conductive textile, which is generally used in heat generation and smart textile, they are ranging between 10 to 10 raised to 4 or 10,000 ohms per square. And very low conductive textile, basically can be used for as an anti-static clothing or for ESD protective garment. So that is in the range of 10 raised to 6 to 10 raised to 10 ohms per square. So basically based on our need, we need to tune the or we need to do the formulation while making the conductive textile. Traditionally, these conductive textiles are rely on metal-based technology, where metal are deposited or applied over the fiber or yarn or directly on the fabric through the coating or various methods. It gives excellent conductivity to fabric, but due to weight burden, loses the flexibility of the fabric. Also, many times it is observed that it involves complex and costlier manufacturing process. And many times we need to import the material here to make the conducting fabric. So to overcome these issues of metal-based conductive textile, there are other alternatives by which we can make a flexible conductive fabric. So
Smita, you may unmute yourself. There were sounds from various corners, so I have muted everybody. You may unmute yourself.
okay. So sir, am I audible?
Yes, yes, you are audible.
Yeah. So means from this slide only I need to start, no sir? Yeah. So as I said, conventionally the conductive textile is rely on metal-based technique, where metal is deposited or applied over fiber or yarn or fabric and made it conductive. This fabric impart excellent conductivity, but due to weight burden, it loses the flexibility. Also, here we need to import the metallic yarns. Many times we need to import the metallic yarns from outer regions. So process become complex and costlier. So to overcome the problems of this metal-based technology, there are some other solutions by which we can retain the comfort property also, and we can make it easily the conductive fabric. So these are the application of carbon powder or conducting polymer or carbon nanotubes over the fabric and made it conductive. Then here the carbon powder and carbon nanotubes can be applied over the fabric through melt mixing or through coating. They are also impart good conductivity to fabric. They add negligible weight over the material, so retain the flexibility. But the problem is that there are environmental concerns with their manufacturing process. So to avoid these issues of CNT and carbon nanotubes, we have used the method of coating of conducting polymers over the fabric and make it conductive. Now the conducting polymer, the synthesis of conductive polymer is very easy. The monomers are easily available. Their synthesis is very easy. and bulk production can be possible. So based on that, we have started working on application of conducting polymer over fabric and made it conductive. So there are many conducting polymers are available, that is polypyrrole, polyaniline, polythiophene, polyacetylene. But most preferable one are polypyrrole and polythiophene because their monomer are easily available. They are environmentally stable polymers. Also, they can easily soluble. Their monomers are easily soluble in water. So that's why most preferable polymers, conducting polymers, are polypyrrole and polyaniline. So the synthesis process are basically can be done through chemical polymerization, electropolymerization, interfacial polymerization, plasma polymerization, or copolymerization. But very preferable and simple method is a chemical polymerization, which involves the oxidative in situ mechanism. So if we see the mechanism of polypyrrole formation, for example, here the monomer is a pyrrole. When now in the chemical polymerization basically takes place through the oxidative force, and that is applied through the monomer. Then what is happens? See here, in this case, our monomer is a pyrrole. We are adding when we are adding oxidizing agent in it, there is a initiation process takes place, and there is a formation of radical cation. Now this radical cation again combined with the other radical cation to form dimer. Now dimer is a stable compound. Again it is getting oxidized to form its cation. Then again the initial radical cation will come and combine with it. So likewise chain propagate and polymer formation take place. Now if we see the structure of polypyrrole, the all monomer units are combined to each other with 2,5 positioning. So alpha-alpha bond. So if this chain continuity is shifted to other side, like 2,4 or so, 2,4 or 2,3 position, then it is called as there is a defect occur in the polymer, and that's why chain continuity will get missed out and the conductivity will get drop off. So this is basically a mechanism of polypyrrole synthesis, and similar way the polyaniline synthesis also takes place. This is happening in the conducting polymer. This is because there is a presence of conjugated bond. Now, in BTRA, we have applied polypyrrole and polyaniline over various types of material on woven sample also, and even for the non-woven sample. We have applied these polymers over cotton, polyester, cotton blend, nylon fabric. And for non-woven, we have applied it for jute and polypropylene. The method which we have adopted here is a oxidative in situ chemical polymerization. For woven sample, we have done the coating with using simple jigger dyeing principle. Here what we have done, we wound our fabric over 2 rollers of the jigger machine and allow it to undergo the monomer treatment first. And in the same bath, then we added the oxidizing agent in the controlled manner and allow it to undergo polymerization. Within 3 to 4 hours, the polymerization completes, and then we can remove out the sample and we can wash it in water and dry it in atmosphere air. That conducting fabric, which is formed with the conducting polymer coating, that can be dried in the atmosphere and can be characterized for conductivity measurement and all. So here, as we have applied jigger dyeing technique, we have already granted patent for this, because while carrying out the synthesis, we have done the modification in the process in terms of temperature maintenance and all. So because here temperature maintenance during synthesis is also very important, because otherwise there are chances of side reaction formation. As I said, the chain continuity can be getting miss out if the temperature is not controlled. So that's why we have done some setup by which the control temperature is taking place, and for this we have already got the patent. And here, while carry out the synthesis, we have varied the monomer concentration, we have varied the ratio of monomer to oxidant ratio, MLR. So all that trials we have carried out for the woven sample, basically in the jigger machine. And then after coating of this conducting polymer over the fabric, we have then assessed their performance in terms of conductivity, shielding property, their morphology, mechanical property, and their durability first. So the conductivity of the sample is generally measured in terms of surface resistivity. As I said you in the earlier slide, our normal control sample is having the resistivity greater than 10 raised to 10 ohms per square. That is, they are having very high resistance. When we are applying some conducting material over it, their resistivity is getting wrong. So now there are two techniques, or we can say the conductive textile are classified two regimes: highly conducting and low conducting. So highly conducting textile are generally used for shielding and for smart textile, which is ranging from 0 to 10,000 ohms per square. So for that kind of sample, ATCC 76 test method supposed to be used. Now this setup we have fabricated as per this standard method. It includes the two pro flat plate electrode system to measure the resistivity of the sample. Now here we are able to measure the resistivity ranging from 10 to 10,000 ohms per square. But for anti-static clothing, which is having resistivity more than 10 raised to 5 generally, so for that we need to apply, we need to use this ASTM D257 standard method, where we are using ring probe method to measure the resistivity. Now, so these are two different techniques for resistivity measurement. Then, as I said, based on the conductivity, we can use it for various applications. So in BTRA, we can measure the shielding performance of the conductive textile with the help of with using the standard test method, that is coaxial transmission line method as per ASTM D4935. So here shielding performance is generally measured in terms of shielding effectiveness in decibel. More the conductivity, we will get the more shielding effectiveness. And as per this standard, we are able to measure the shielding performance in the frequency range of 30 megahertz to 1.5 gigahertz. This covers the EMI signals generated from the mobile phones, from the microwaves and the radio waves. So in BTRA, we can measure the shielding performance. And for our fabric or our synthesized sample also, we have performed this test. We also can measure yarn resistance for the conducting yarn, but the surface resistance we can measure only for those sample who is having resistance less than 10 raised to 6 mega ohm. So basically for highly conducting yarn, we can have a facility to measure the resistance. Also, we can check the heat generation through the conducting fabric. Basically, what happens, being conductive fabric, it is having a low resistance. And when we apply some voltage to it, it will increase the current flow and it is getting converted to dissipated heat. And if we insulate it properly, that heat can be retained for a long. So this principle is basically used for high altitude clothing and for electrically heated heated pad or jackets, basically. Now results and discussion. So these are basically these results we have got for the PPY coated woven sample and for polyaniline coated woven sample. As I said, using Gigadang principle, we have coated PPY and PANI over the various types of sample, and we have achieved the resistivity from 20 to 7,000 ohms per square. So which is very wide range of resistivity and found to be suitable for smart textile application and for shielding purposes. Also, we have done the coating over non-woven sample, and maximum or lowest resistivity we could achieve there is a 20 ohms per square with the jute, and with same formulation that in case of PP we are able to achieve up to 120 ohms per square. So here we can see the uniform deposition of polymer over this non-woven sample. Now for these samples, we have measured the shielding effectiveness. Now the shielding effectiveness is basically can be converted to shielding efficiency. 20 decibel shielding effectiveness means around 99% shielding performance. 15 dB means 95%. Basically, there is one logarithmic formula. Based on that, we can convert this shielding effectiveness to shielding efficiency. So, with the conducting sample, minimum 10 dB shielding effectiveness we supposed to achieve. Then only we can say that there is a 90% attenuation towards electromagnetic signal. So here with this 20 ohms resistance, In case of jute, we are able to achieve 20 dB shielding effectiveness, which is nothing but 99% attenuation. And based on that, we can say that this material can be used for shielding purpose in the various uh, area, and in case of casual wear, in the electronic product, as a shielding enclosure basically. So as we, in case of woven sample, as we have got various range of conductivity, that is from 20 to 7,000 ohms per square. As I told you, we can use it for the smart textile application and heat generation. So based on that achieve resistivity, what we have done, we have developed some prototypes. So one is this smart mat. Here we have placed our polypyrrole coated sample inside this mat, and we check its performance as a switch or as a pressure sensor. Now this is basically called as a smart mat. Here we have placed our conducting fabric. If anybody keep his feet on it, we can get the signal in terms of sound or in terms of light. So for occupancy detection, these samples can be used as a pressure sensor or as a switch. So in the hospital or in the security area, in the cars, we can use this kind of material or application. So here also same application is there, only we can get the signal in the form of messages. So as I said, in the car, if we put such a material inside the uh, driver, if we place it in the driver's seat, or over the, what we can say, covering of in the car, if anybody touches that, we will get the signal in terms of message or in terms of siren, like this. So using that polypyrrole coated fabric, we have tried for this prototype. Also, we have checked the performance of it for the heat generation. Here also what we have done, we have applied around 12 to 24 voltage over the conducting fabric. We found that within 1 minute, about 10 to 15 degree rise in a temperature we have achieved. And if we insulate it properly with the insulator, that is remaining hold for around 50 minutes. There is a slight drop, but we can hold it for long duration. So likewise, for heat generation purpose also, this conductive fabric can be used. Also, we have checked we have analyzed its performance toward gas sensing. Here what we have done, the polypyrrole coated sample, we have allowed it to expose through the reactive gases like ammonia, ethanol, and we found that there is a change in the resistance. And when we take out that reactive gas source from there, again the resistance come back. So based on that, it shows the performance toward gas sensing. So here also we got very good result. And the one more additional property this conducting polymer are found to be having, that is an antibacterial property. That is its inherent property because of that the carbon nitrogen bond. So this way we have done lot of work on the conducting polymer coated samples. We have around 9 to 10 peer review publication on that. One granted patent for synthesizing this ICP based sample. Also, we have a publication of 2 books, which is including all our published papers and all. So in summary, we can make the conductive samples successfully with using chemical polymerization of conducting polymer. They can give a very vast range of conductivity, and that which can be tunable, and based on that they can be used in wide range of application. And it is found the application of conducting polymer over the fabric is very simple. The bulk production can be possible, and it is applicable to all kind of material. So with this, I would like to thank you all for your patient hearing. So please, any suggestions, questions are welcome.
So
Thank
thank you, Smita. You have very good control on your subject, the research which you have done, because the confidence and the way you spoke, you have completed the presentation much before time. So now we have more time for experts to comment on your presentation, and then we will take up question answers. So first of all, I would invite our veteran Dr. V.K. Kothari to speak on Smita's presentation and her work, research work. Kothari sir, please unmute yourself. and speak. Kothari Saab.
Hello, can you hear me?
Now, yes. Yes.
Good evening, sir.
Okay. Good evening. Now it was a very nice presentation, and obviously it covered everything regarding the conductive textiles and the way the things are going on, and probably these have many applications which is going to be useful. And I would congratulate the author for very nice presentation. Now, maybe if she can really throw some light on what is the future direction for these materials, matlab, where are we going? Because there are possibilities of using them in various things, including the smart textiles. So, what she feels would be the major use of these conductive materials, which she is looking at the moment.
First of all, thank you for the comment. And yes, sir, we found that means tremendous scope for this kind of material is in the wearables and smart textile area basically. If we today itself I have checked for the CAGR, it is CAGR and the turnover, it is around 1.2 billion, 2 billion US dollar currently. But the expected growth up to 2032 they have given is around 37 billion in this area. Because
Okay.
for the smart textile region, they for the smart text currently there is so much awareness about fitness, and also there are many products, smart products are coming in the market. There is a need of sensors and all. So based on that, the good market is there, I can say. And yes, there is a very good future in this area, basically.
Good. I think Kushal Sen is the one. Professor Kushal Sen, if he's there, he is the one who has worked on conductive materials and conductive textiles. Maybe he can really throw some more light on that.
Thank you.
Hello.
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 Are you
Yes.
listening, Smita?
Yes, sir. Yes, sir. Yes.
Professor Kushal Sen is there. Lal Sahab
No, sir. Today is not.
is not there. Okay.
Then before I invite the
Open.
other expert, I would request Smita to unshare her screen and request Bajpai to share the invitation of our conference, 14th December conference.
Okay, sir.
Now I invite Mr. Desai, because he is his guru and he is hardcore
Yes.
research fellow. So he would be a better person to comment on our presentation, quality of our work, and the possibility of its implementation in the industry. Desai ji.
Well, thank you, Lalji. What I should say, because it is her work. She has done some wonderful work at BTRA, and in fact, she is continuing in that area as well as in water treatment, as far as I know.
Yeah.
And the point about this is Professor Kothari was asking, no, future thing.
Yeah. Yes. Sir.
Now, this is a smart textiles, as she mentioned, is going to be the new area. And for your information, the Bureau of Indian Standards has set up a separate sectional committee now for the technical committee for the smart textiles, wherein these fabric sensors are going to be the most interesting applications in all kinds of smart textiles, whether they are ICP coated or otherwise. So this, I think, is a tremendous area, and I'm sure she is continuing to work on that. I think she didn't say anything about plasma polymerization, which also she has worked earlier.
Yes.
In
Yes.
fact, she has
Yes.
not covered many other areas which she
Yes.
has
Yes.
worked, I
Yes.
think. So plasma polymerization is another area. In fact, BTRA has worked a lot on plasma processing also. In these days of water conservation, I think that is a very interesting area for processing people. So that is how it is. She has done a good work, I think. It is for the others to comment, and maybe many questions are there. She should answer all the questions.
Yes. Thanks.
Thank you, Desai ji.
Thank you.
This Bajpai ji, this only quarter of the page is visible. Can you share the full?
Sir, I am trying. Sir,
Now
in the
I
meantime,
request.
sir, in the meantime, may I take some questions?
No, let us first take the views of expert and then we will take up questions.
Okay, sir.
I now invite Dr. Kuldeep Sharma to speak on the quality of presentation and quality of work. Dr. Kuldeep Sharma, unmute yourself and speak.
नमस्कार लाल साहब और सभी भाई बंधुओं को सप्रेम नमस्कार. Quality of presentation has been very quick and smart one, and they are young scientists. They are delivering their best to the institution. But when we interact on our platform, where we coordinate with the industry members, individual as well as professional corporate members, we try to see the benefits for both the researchers, academia, and the industry as well. It will be in the greatest benefit of the industry members present here, other than the researchers over here, that the technologies which have been developed and some of the technology issue we were talking about has been commercialized with some entrepreneur or any startup has been initiated through your efforts.
Yes, sir. Yes, sir. Sir, we are.
You may present us, please.
Okay. Sir, one of the application currently we are working for the commercialization, that is for ECG sensor. We have developed this PPI-coated sample and giving them as a ECG sensor. It basically act as a transducer for which converts the ionic impulse generated from heart to the ionic signal. So that way we found that their performance is good, and we are currently working with the one of the industry partner, and we are on the way. We have just signed the one non-disclosure agreement with them. Also, we are working with another party for making the conductive yarn, and that trials are under progress. With them also, we have filed one joint development agreement for making conductive yarn. So yes, sir, commercialization activities going on for a smart textile.
That's good. Very shortly, you are going to see this invite for our next emerging conference in the month of December. You can think of some presentation which culminate into the commercialization of your work in a research institution in the field, industry field. Thank you very much for your nice presentation and knowledge given to us, and it has taken us back to the college days that we used to read and study these fundamentals. Thank you, Smita.
Vadirajji, if you are there, then please tell about yourself to the participants and give your comments. Vadiraj Tilgulji.
Hello. Haji, Dr. Lal.
Hello. Yes, you are audible.
My name is Vadiraj Tilgul. I deal in yarn, basically all kinds of yarn. I live in Turkey, so I sell yarn from India, Indonesia, basically into Turkish market. So I'm also interested in technical textiles and technical yarns, and that's more of an academic interest for me. And this conference you're talking in December, are the speakers been announced, or the papers and speakers are not yet? Wanted to know.
Vadirajji, all details are there in the flyer which is uploaded on our website, and
Okay.
users are also allowed to participate and also give presentation.
Okay.
I have something to present, but it is physical, not in hybrid mode. Correct. You have to come to India to make your presentation.
Correct. I am actually December. I am going to be in India, but dates are not clear.
Make your schedule accordingly. This is on 14th December. The flyer is seen on the screen. Not flyer. One page invitation is seen on the screen. And flyer is available on our website. and we
Yes,
will
sir.
send to you also.
All right, all right. Yeah, thank you, doctor.
Dr. Shanbag, please give your comments. Dr. Vinod Shanbag, please unmute yourself and speak.
Good evening, everyone. First of all, it was very pleasant for me to be among some old BTRA folks who've been, with whom we have had partnerships in the past when I was working at Atira. But leaving that aside, Dr. Smita made a very interesting presentation. According to me, in conductive textiles are certainly taking a lead because of their widespread application, as Dr. Smita has expressed. And I have myself personally seen their application in places like Siachen, where Indian soldiers have been using these kinds of, conductive textiles for the clothing that they wear in the in the difficult circumstances. I have also seen their the clothing able to give live information about their health statistics and so on and so forth. So this is a very interesting field, and I'm sure that taken forward, it'll end up providing a whole lot of new developments, which will be very, very beneficial to India. So I wish Dr. Smita all the best. I wish BTRA all the very best in this field.
Thank you, Professor Shanbag. Now only I will invite Mr. A.K. Upadhyay, who has been president in many companies, and now he's serving a different field other than the textiles. You will speak about the quality of this webinar presentation and opportunity of this technology to be implemented in the textile industry, because you have wide experience of textile industry.
Right. Thank you very much, Mr. Lal, providing this opportunity. First of all, congratulations to Smita. Am I audible? My voice is clear?
Little louder.
Okay. Okay. Congratulations to Smita for presenting a very informative presentation. It was very informative, in fact. We have been using such type of materials in a small scale as a anti-static agents, sometimes in our fabrics, and some special spirited finish also, but not much. But the application of conductive textiles is certainly going to be a huge market in the coming years, to be used in the industries as industrial use. So I feel it was a very informative session and nice presentation, very smart presentation. So that is what I can say. And my congratulations to Smita once again, and to a young scientist for working in this interesting area, which is the future for the industry.
Thank you, sir. Thank you.
Now I invite Dr. Surendra Kumar to take up question answer session, and participants who have not put their questions in their chat box, they may please raise hand and then ask their question after unmuting themselves. Dr. Surendra Kumar.
Thank you, Dr. R. Chairman, NISTI. Good evening to all. At the outset, I can say that Madam Smita Deogaonkar-Baride has given very good lecture on the subject of conductive textiles and having very enlightening talk. So she has covered this coating of conductive polymers on the fabrics using polypyrrole and polythiophene. these two. And now I would like to take questions. There are 3 questions right now. First question by Shri Ravi Shankar Gopal. He has asked that what is the effect of treatment on the tensile, stiffness, roughness, abrasion resistance, particularly in non-woven fabrics? Smita.
Sir, basically for woven samples, am I audible? No?
Yeah.
Yeah.
So for woven samples, we have measured all this property, basically tensile strength and roughness. So there we found that the abrasion performance was found to be improved with the plasma treatment. In case of synthetic material, there was not much problem for natural fiber because there is a absorption and adsorption. Both phenomena was there for polymer coating. But for synthetic material, we have done the plasma assisted polymerization. So that problem was solved there. Now in term for non-woven sample, yes, there is a issue. So there in that area, actually, we haven't got much, but there we have worked for making composites for shielding product. So there what we have done, we have made the non-woven CP coated non-woven sample and we have made the laminate of it, and for that we have checked the shielding performance because yes, the non-woven sample, yes, there is a issue of what we can say, the abrasion and all. So that's why we went towards the what we can say, laminate making. Am I audible? No,
Yeah.
actually my slide
Yes,
everything is.
You are very well audible.
Yeah.
More than everyone.
Yeah. So this way, actually, we have tackled these 2 things. For woven sample, yes, we got very good result in terms of tensile strength also, even in for abrasion also. Yes.
Nice. I do hope that the answer is clear, question is clear to everyone. Now, next, second question is from Mr. Sachin Langdage. He has asked about the fastness property of the product. What are the...
Yes, sir. Yes, sir. That is also a very good question, I must say. See, wash durability of polymer coated sample is not, means with surfactant washing, it is not recommended because yes, if there is a surfactant added over it, the what we can say, basically the conduction in that sample is due to hole formation. If we are adding surfactant through soap washing, there that will get what we can feel, and yes, surface resistivity loss will be there. So that's why what we have recommended here to go for dry cleaning. See, in most of the if you see the prototypes, in most of the application, we have used it as an inner lining material so that it will directly not get exposed to the water or environment directly. So that's why it is recommended most of the conductive textile are generally used as an inside or lining material so that this problem, I think, can be what we can say, can be keep or what
Yeah, correct. Okay. Now there is one more question from Mr. Mukesh Suneja. He has asked, he want to know more about the use of ESD, that is carbon content fabrics. And it's he want to know more about the use of ESD, that is carbon
Dr.
content
Surendra Kumar, you speak little louder.
Okay,
you are faintly audible.
Okay.
Or Mr. Suneja, you can unmute yourself and ask your question.
Just ask your question,
Yeah, am I audible?
Yeah.
Yes.
Thank you very much. Yeah, my greetings to all. This is Mukesh Suneja. My company name is Conscious Clothing Private Limited, and we are manufacturer of clean room clothings based in Surat. So my question to you, Ms. Baride, is what are the properties of ESD fabrics, electrostatic discharge fabrics, which has a carbon content, and how to measure it? Because for clean room clothing, for farmers, we need to measure it also, but the laboratories are not well equipped, so we have to send it to foreign land to get the testing done.
Sir, actually very good question, and I think BTRA can be your solution for getting tested this. See, ESD performance we are able to measure in terms of resistivity measurement, first of all, so that we have. Other is a through the static onisometer machine. There, see, this is basically instrument where we are applying 10 kV voltage, which is basically a what we can say, it is a simulation of the static charge basically. So through that we are generating we are applying 10 kV voltage over that material, and we are looking in how much time it is getting decay. So you can get the value in terms of half decay time and charge accumulated over the sample. So that is basically given you the idea of the performance of ESD clothing or anti-static clothing. So actually in BTRA we are getting that kind of sample. Basically they are using it in the pharmaceutical industry for drug filtration. And, yeah. So it is as per ASTMD 4938. I'm not able to recall that standard name, but yes, we have that facility.
So may we have the contact details, please, Ms. Baride?
Yes,
I can connect you. I can connect you.
I think BTRA website you can get it, or I will add it in my chat. I will add it in the chat box, so you will get it.
Yeah, so that I can have a one-to-one contact with you in case of more details. Thank you.
Okay, yes, sure.
Okay, one more question
Yogesh
is
Sharma is a
from
great NISTI lover. He is here. He is very prompt in responding to any communication of NISTI, and he participates in almost all webinars. Request Mr. Yogesh Sharma to speak something about him, and then about today's presentation and Smita's total confidence on her subject, total control on her subject. Mr. Yogesh Sharma, please unmute yourself and speak.
Okay.
I think he has left. Anybody else has got any question? Please unmute yourself and speak.
Dr. Lal, this is Ravi Shankar. I have one question
Yes.
to Smita.
Yes,
Yes, please.
Are you able to hear me?
Yes, yes.
So my question is, she talked about the measurement of decay of the static charges on the fabric. I want to know for how long. I'm a consultant to the non-woven industry, so I have a lot of work done on setting up projects and also product development. One of my problems in fabric is in filtration area, where I am developing a product for filtering very fine dust, and have to develop static charge in the fabric. So and I have to retain it for a period of 1 year, so that it works with the same filtration efficiency over 1 year period. We already mixed some fibers like polypropylene, nylon, and everything to get the triboelectric series. But what is the problem we have today is that we are not able to measure how long this charge will, whatever we develop because of the triboelectric series. How long it will take for the charges to decay over the service period. So how will you test it? What is the test method you have?
Sir, that is with the help of static onestometer. That instrument we can measure that in terms of decay time.
Yeah.
So there we are applying 10 kV voltage, which is simulating to this static charge, and we just check it in how much time it is getting dissipated. So as per 4238, ASTMD 4238 standard test method, we are measuring that.
But how will you estimate whether it will last 1 year or whether it will last 6 months?
Okay,
or whether
that
it will last
durability of that filter. Okay,
Yeah.
okay. I thought in terms of measurement.
No, the charge decay over 1 year or charge decay accelerated aging. Do you have some kind of in the textile
actually
weatherometer you have?
No, only maximum time which we can check means for accumulation, that is 300 seconds. Because we are checking it for anti-static now. So that fabric is supposed to be having a decay time less than 300 seconds. So that's why in we have a facility where we can check that decay time up to 300 seconds only.
Oh, I see.
Not more than that. Yes.
So we will have to do the aging and then bring it back to you for testing again.
Yes.
That is the only way.
Weatherometer, I think in one of our lab is having. If I come to know everything, something, I will just get back to you, sir.
Please let me know. I will.
Yes.
I don't know whether I should give you my number or you will give me your number, whatever way it is.
Yeah, sir, I have given my email ID also there, Conductive
Yeah.
BTRA India, and I'm just typing my.
Can I add, Dr. Lal, can I make a sentence here?
Yes, yes.
Yeah,
You just
Ravi Shankar,
Yeah.
Ravi Shankar, you know,
note down my number 9868
Okay.
Ravi Shankar,
47
1 second. 9868
475582.
475582. Okay, fine.
On that,
I will-
you send me your message on WhatsApp, and
Yeah.
I will give you Smita's presentation as well as her email also.
Oh, that's great, Dr. Lal. Thank you so
If
much.
it is
Thank you.
permitted by Smita.
Yes, sir, yes, sir, yes. No.
yeah, I
Anybody
wanted to
else?
tell Ravi Shankar,
Yeah.
you know, this long duration durability, there
Yeah.
even in some other cases like geotextiles and all, accelerated tests only are available. You can't
Yeah.
keep something for a year or all that. So
Yeah.
what is suggested is sometimes extrapolations may or may not be correct, but
Yeah.
the solution perhaps is lying in at your side, because you will have to keep it for whatever duration and go on testing every now and then.
No, no.
Otherwise, there is no other way.
No, in UV and all, see, you have accelerated weather.
No, that is
we
different.
have-
You see, that is light
Yeah.
fastness or whatever watch
Yeah.
fastness.
Same,
That is different
similar.
because that is 500 hours, 300 hours and all. Even there, it is not for years together, because we test a lot of geotextiles and there
Yeah,
the durability over a period, say 10 years, 15 years, it's not possible.
No, it is extrapolated by doing only few hundred hours, 1,000 hours.
But
It is an
extrapolation is
extrapolation.
not linear, so it may not be correct actually. That is
Okay.
why sometimes even the road people, they dig it out and send it for testing.
Yeah, that is okay. That is for practical. One is
Yeah,
theory,
that is
one
what
is
it is.
practical. Okay.
Another thing I wanted to tell Smita, you know, even earlier polypyrrole treatments
Yeah.
were done much earlier also to your work. But
Yes, sir.
the uniqueness or the specialty of the work done here by you people is that you are able to develop certain products and already commercializing it and setting up for the first time perhaps to test all these kinds of materials, including
Yes.
EMI shielding and other things.
Shielding.
That is the advantage here.
Smita, the extension to my question, which is already, I think, is there, is the thermal conductivity and the moisture absorption in such fabric in which you have treated. Particularly, suppose you say you have treated a cotton fabric. Have you measured the thermal conductivity and also the moisture content over a period of time?
Thermal conductivity we haven't measured, sir.
Yeah.
No, means in terms of thermal conductivity we haven't checked,
Yeah.
but moisture also means there was not much effect on that we found.
No, because these two properties, if you are to, then it can be used in the garments and other places.
Yes.
If the thermal
Yes.
conductivity is increasing, because the conductivity is increasing, then it can be used for temperature control to reduce the temperature in summer rather than in heating it. What you are doing, it can reduce. So that is a big application compared to in a summer wear compared to the conductivity textile. That's why I'm asking you.
Yes. Yeah.
Okay, now let's come to the next question from Dr. Patra. He has asked whether anything you would like to speak on graphene and MZNA applications. Have you any
Graphene
idea about graphene and
Graphene
MZNA?
and mixin.
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 No, sir. Means frankly speaking, I haven't did that much work on that. But I think while synthesizing the coat, while doing the coating over it, the networking of graphene is to be properly. So I think that way formulation is supposed to be done. So that is a major parameter there for doing the synthesis. But frankly speaking, I haven't done much work on that, sir. Frankly speaking.
Okay, then comparing between polypyrrole and polyaniline, polypyrrole is a much better product. That is already an established fact. Any major demerits with polypyrrole?
Yeah, atmospheric aging was there, but with the help of sulfonic acid, that problem also got solved. Means while doing the polypyrrole synthesis, we need to add some sulfonic acid dopant, so that atmospheric aging also can be Black color.
And
Yes,
when
sir.
you normally apply it on a fabric, the
Yes, sir.
fabric turns dark. It becomes almost blackish.
Yes, yes.
So that is again a disadvantage.
Yeah, black color. Yes, yes. Color. Yes, sir. Color is there. Color is. Yeah.
So you don't have any antidote to that, right?
Yes. No, no. Means there we cannot do. The color will be black only. Then only it will.
Yeah.
And if it is green, in case of panning, it's supposed to be green.
Okay, thank you.
Any other question, Dr. Surendra Kumar?
Yeah. There is one more question from Kamila Sharma. She has asked about the skilling opportunity to their scientists in this field. They want to see that the conductive textile will have a widespread applications. They want to have some training type of skill, as this Kamila Sharma is working with the Directorate of Skill Development, Government of Madhya Pradesh. So she wants to know whether this type of skilling opportunity can be given to their scientists in this field.
Yeah, I think, but for that, you need to drop an email to our director, head of the institution, and from them, I think you will get the response. Yes, we are allowing the students for internship and all, but that need to be get confirmed through our director, sir.
Okay, nice.
Yeah.
So one question is from my side also. Have you checked the KS value, Kawabata evaluation system?
Okay, strength value, na? Means K by dye strength or color strength.
Kawabata evaluation system is there.
Okay,
Have you checked, because in the Kawabata evaluation system, we have to check various properties of variability, means handle and all these things are there, drapability and all these things. Whether you checked for this?
No, Kawabata, they have not worked.
No, sir.
They have not worked. Gotcha. Okay. Regarding this, one more question is there. What is the degree of polymerization when you are carrying out polymerization in the jigger? What is the DP?
Degree of polymerization.
Pyrols you are using, no? This is polypyrrole.
Yes.
Pyrrole, when you are just carrying out the polymerization, I think the DP is there, which is applied on the fabric to make it more, conductive textile.
Yes. Optimum.
Any DP?
She doing synthesis of five. She is not doing synthesis. Our work is mostly on application side, no?
Yeah. No, but when we are
synthesis.
using the pyrrole, there is polymerization is going on in the jigger.
Yeah.
Because no, that DP I want to know. You know that. If you check that.
Yes, I will check it. I will check. Actually, I haven't checked.
Okay, thank you.
Yes.
So now, thank you for your nice presentation, Madam Smita Deogaonkar-Baride. Your talk is very enlightening.
Yes.
Yeah.
Before I invite Shri A.N. Bajpai to say a formal vote of thanks.
Just a moment, Chairman, sir. Just a moment, Chairman, sir. Excuse me.
Yes. You are welcome.
We have with us Shri A.N. Sharma, who has been a pattern with us and very regular in our webinar. He has a variety of experience in industry, more than 5 decades. We also can invite him for enrich this deliberation on the subject, or otherwise throw light on our coming event, and so that we can seek his guidance for the making this coming event successful. Along with him is also Mr. M.K. Garg is seen today. We welcome him on this platform again and again. He is also welcome to interact with us on this platform. Thank you very much, sir.
Thank you, Dr. Kuldeep. I am thankful to Smita for her beautiful and fantastic presentation, full of knowledge, and the way questions have flown into the chat box and in person. It shows that her presentation is to the interest of everyone present here. I am thankful to my team, Dr. Surendra Kumar, and my predecessor, Dr. Kuldeep Sharma, Vinod Shanbagji, Guru, Dr. V.K. Kothari, and Dr. Badirat Tilgul, who is joining from overseas, and he always move throughout. I don't know where he is now, either in Paris or in London or anywhere else. So I thank him that he has made it a point to join each and every seminar. Dr. Shanbag also knows him very well. And I have first met him at Bharat Tex. He was introduced by our Stephanie, our TI executive.
Yeah.
So I'm very thankful to you, Bhadiraj ji. And you
Thank
are
you, Dr. Lal.
well invited in our conference. I again request all the participants to please spread the message of our conference, which is happening in December 14, and spread the share the flyer which is available on our website. And I will also share to everyone the means email addresses of all of you are available with me, with us, with NISTI, and request you to spread it and means help in making the program a grand success by huge participation and also the financial help which you can organize it. So thank you very much. And I now invite Shri A.N. Bajpai to say a formal vote of thanks to everyone.
Yeah.
Bajpai ji.
Thank you, Dr. Lal sir. On behalf of NISTI, first of all, I am thankful to you. You are always taking pain in arranging such a wonderful seminar. Thank you, Smita Deogaonkar-Baride, for fantastic presentation, very nicely articulated PPT. Actually, this is a new subject for me. New subject for me on the conductive polymer coated fabrics. And I think the days are coming for this technical textile, and it will have a wide scope in coming years. I am thankful to all the participants, all the audience, especially to our veteran, Dr. Kothari sir, Desai ji, Professor Shanbag, Dr. K.K. Sharma, Dr. Suren Kumar, A.K. Upadhyay sir, Ravi Shankar sir, for taking participation and active participation in this webinar. And in the last, I am thankful to the audience who spare their time for this webinar. Thanks to all. And before summing up, I am requesting everyone to attend the NISTI IIT conference on sustainability in textile and clothing on the 14th December 2024 at the IIT complex. Thank you all. Thank you, everyone.
Thank you. Thank you.
Thank you, everyone. Thank you, Sharma ji, Arun Sharma ji. And thank you, Dr. Kuldeep Kumar Sharma, for reminding me to thank him. He is regular participants in all our webinars, and he is a great NISTI lover. Great. We have all blessings and shubhkamnaएं from him for success of all our event. And he is very down-to-earth person, having lot of experience, having worked on very high positions, but still very down-to-earth. It is pleased to meet him always, and we consider him the boy next door. Thank you, Sharma ji. Thank you so much. Thank you, everyone. So shall I now end the event?
Thank you. Thank you to all.
Okay, thank you, everyone.
Thank you, sir.
Thank you, Dr. Lal.
Thank you.
Thank you.
Thank you,
Bye.
sir. Thanks to Chair, sir.
Thank you.
Thank you, Dr.